Hello everyone, this is Sam. I'm back for another video, and again we'll use the same lab. In this lab, this is a VXLAN deployment here over an OSPF backbone. I do run all my Python scripts, test them on this lab. So eventually we'll get to run some show commands to verify the VXLAN operations on or the VTEP tunnels over this on this lab. But for now, let's go on and discuss some of the methods that were developed using the Genie library to do certain tasks or automate certain tasks. But so last time on the last videos we've talked about some of the methods that I've written, and some of them will still be included, but this time I've put them under this class, and I named this class Network Automation because this class will this Python class will have a variety of methods to do certain different tasks, right? Again, here we are still using the Genie library, obviously, and then we're importing time from Python, right? Built in Python. This class Network Automation, let me get here, will have this method show interfaces, show CDP neighbor, get interface list, and show IP OSPF neighbor. This was the new method that I've written to parse a show IP OSPF neighbor. But again, there's some more to it, right? You write a method to do, for example, a simple show IP OSPF neighbor. The power comes in when you start using conditional statement leveraging the state of this peer, and depending on the state, you may suggest that the peer is down or do a task, right? It could be an execute command that may go in there and bounce or do something in order to fix the problem, right? And this is where the automation comes in hand. So we're still using this test bed. Again, I was saying I have core A, core B, and core C running OSPF, right? But we're not only going to just look at the OSPF, we'll look at how using a class. First of all, let's talk about class before I proceed, and why I put my method under this class, so I can instantiate multiple objects, right? And the class helps me do that, right? Quickly going over it, you have your init constructor. This is where you do your instantiation. I have my YAML file. This is all function call, right? And this captures a list of items. And then on the first method, in which you discussed last video, basically it was as simple as creating a file, closing the file, and then appending to this file make some text to make it look clean and more readable. And then obviously the self.host name is this list that I've acquired from a function call. So, and basically I'm connecting to the device, right? Because I'm doing a for loop through this list, and then I'm connecting to each device. So this is a repetitive block, right? And then I do connect using this method, which belongs to the Genie library. It's been built, and I don't have to reinvent the wheel. Again, this is I'm appending this to make it more readable for the user, and you'll see in a few minutes when I run this method. And then I parse the show interfaces command, and this is sent to the IOSXE, and the output is obviously mapped to this variable called output, right? Now, I have this while loop, and all it does is if you type continue, then you can generate output for this items, which are all attributes under an interface, right? Configuration, metadata, whichever you want to call it, and then the else quits and gets you out the loop and end the script, right? On the other hand, the show CDP neighbor does something similar. It does leverage again I was talking about earlier, instantiating through this class, and then I do run through each of this is a list, right? Item on this list, and then do something, do show CDP neighbor, right? First I configure CDP if it's missing. Even if it's not, I do configure it, wait for some time, and then basically this is sometimes when you enable CDP globally, and then you enable it, you run it globally and you enable it on interfaces. You have to give it some time for it to start running, right? And then I do run a for loop. I do send a command, right? Get an output, map to this output, and it's parsed. It's a dictionary type. And then I do parse this output into something readable. Now, the get interface list basically gives me a list of interfaces on the router, so I can refer to it. I can tell how many interfaces I have on that router. So, and then the last one that I wrote was show IP OSPF neighbor. Yeah, I wrote it leveraging again the Genie library, and it's method parse, right? The show command basically is a function call. You can see it here. I have it as a string, right? And running through each of the device within this list, I've sent the show command, right? And then I'm parsing the output using for loops. Okay, so let's get back on this Python file. So this Python file basically calls on this class, and this class has all these methods, which makes it easy for me. I collect a user input. You can put in as many routers in the labs. So in our case, it's core A, core B, and core C. And then this is put into a list called my list, and it's sent to the class, right? Again, it's called function call, right? Using these attributes. This testbed2.yaml is basically the same file here, right? And then my list is the router list or device list. Now, this is stored into basically I'm calling on the class, right? I'm importing the show interface class, and I'm using class network automation, sending this, and then I can leverage now using int underscore class. I can leverage each of its method, right? So in this case, we're going to do the show CDP neighbor, we're going to do the show interfaces, and we're going to do the show IP OSPF neighbor. Okay, and we're going to send the command show IP OSPF neighbor. That easy. So we're going to run this. Let me scroll up. And then again, enter devices hostname separated by a comma. Pretty easy. We're going to enter all three. And then again, it's going to take a second because, just as I said, I like to always make sure that I enable CDP, and I give it 10 seconds for it to go ahead and apply run it globally and then enable it on the interface. It takes some time. So let's go back. So it's done already, core A. So you can see this output is pretty clean. I think it's pretty easy to read. I have core A that gig 4, and you see this connection to gig 2 that core C, right? Obviously this is the domain name. Okay, so I know that core A is connected to core C on gig 2. That's the representation. And you have the same thing on core A, core B, core C, right? Now you're connected to core A. It's asking you, hey, which interface do you want to gather information from? Well, in my case, I'm interested in gig 4. So in here, we'll enter gig 4, right? and then it's requesting you, hey, do you want to continue or quit? So continue continues, and quit ends the script, right? So we want to look at the IP address. We want to make sure the interface is enabled. We want to see line protocol in our case, right? And then the operation status, maybe a MAC address, why not? Oops, I gotta put a comma here. Let's do a MAC address. And then I like to copy this so I can parse or paste this to the, so there we go. And then we're going to quit this. And then obviously now we're on core B. It's like, hey, what do you want to look on core B? Which interface? And I'm interested in 3 because 3 connects to core C, right? All right, so we'll do the same thing. And then we'll continue. We'll paste that. And then we'll quit. Now we'll go to core C and do the same thing. On core C, which interface are we interested? So we see that core C is connected to B on 3, but let's say I want to see 2 connects to 4 on A. So I want to see 2, right? So in this case, I'll enter 2. Okay, we'll continue, and then we'll want to see the same information, and we'll quit. Now the next one was the OSPF neighborship. So you may ask, hey, where's the output? So the output for the interface information has been put into a file, right? So let's do this for ease. So like I said, I was talking about parsing and putting an output through the file, but very organized output. Looks pretty easy on the eyes, and that's exactly what it did here. Because the method parse that belongs to the Genie library helps you, puts the output into a dictionary that can be further exploited to put the information in a readable and much easier way to read, right? So here I have my IP address, right? I got the state, the status, is it enabled or not, or it's true. Line protocol is up, operation up, MAC address, I do have a MAC address. I can, and then the same thing for B and C. Now looking at the OSPF neighborship, right, you can see that this output is much easier to read, right? OSPF neighbor on, so for core A, OSPF neighbor on interface 4 is 10.10.10.10. The neighbor interface address is 10.2, and then the priority, you have the state and you have the dead timer. Okay, this is the same thing for core B and core C, right? Obviously you have core B, and then its address, and you have core A and its address, right? If you refer to the output, you look at core A interface 4, right? It's actually that's core B. Core A is .1, right? And then the OSPF neighbor for core C obviously is 11.11.11, and the neighbor interface address is .1. So you can tell that's pretty accurate, right? So basically, Python does provide you the ability to parse and your output from a command from a router, and put it in a format that is readable and easy on the eyes, right? And then, like I said earlier, you can utilize these, like for example the state here, you can utilize that and make it so that you can run some conditional statements in order to test and you know, to test and provide some more outputs or react, so you're more reactive. So if this interface state, let's say if this OSPF peer state is, let's say, on the init stage, right? Or you can have a conditional statement using this line to further do some things is pretty powerful, right? Anyways, I'll do an example of it in my next video using this method. In another video I'll do that. Okay, well, that's about it for today, and I'll see you guys in the next video. Thank you for watching.